Hey, Shaun, we cannot hear you. I believe you're on mute. Can we try that again?
Much better.
Yeah, that's way better.
Okay.
Hello again.
Let's try that again. All right. Good morning, good afternoon, good evening. Very excited to join you today to share some information about .NET MAUI and Blazor. This is the first time I've participated in an ABP conference. I'm very excited to be able to participate. I'm Shaun Walker. I guess my claim to fame is that I was the original creator of an open source web application framework called .NETNuke that was released way back in 2003. So that's just a little over 20 years ago. It was a framework that was designed to accelerate the productivity for developers, much like the ABP framework is designed to do today. I'm a Microsoft MVP. I've actually been lucky enough to be an MVP for Microsoft for about 14 years now, also an ASP Insider. I've more recently been involved with a new open source project called Oqtane, which is, I guess some would consider it to be sort of the successor of .NETNuke. Is essentially a web application framework that is built using all the modern Microsoft technologies, but emulates a lot of the same capabilities that existed in .NETNuke. I'm also the chair of the .NET Foundation Project Committee, where we oversee sort of the intake of new projects who apply to become members of the foundation. Currently, there's more than 100 projects that are part of the foundation, and that includes both Microsoft-based open source projects as well as community projects. I'm a Canadian by citizenship, although I'm currently living in the United States in Florida. And I've also been lucky enough to participate in a lot of different books over the years. I would have to say, though, that writing books is a lot of work, and I've seen a lot of actually contributions in this space in the last year or so, especially around the Blazor community, people writing books, which provide a lot of value to developers, but it's definitely a lot of work, and I appreciate that. And I was introduced, I guess, in the initial slide as CTO Professional Services for Cognizant, and actually that was my role up until last week. So my new role, basically starting this week, is something that I'm going to be announcing shortly. I'm basically starting a new venture that's independent, that's going to include a lot of different aspects to it from my past around professional services, product development, and things like that. So it's going to be sort of an exciting new time for me in my life. So let's dive into the topic of this presentation, which is Blazor and .NET MAUI. And I guess starting from sort of the high level, one of the things that developers have long struggled with is this notion of multi-platform application development. So the ability to build applications that work on all of these different operating system and devices, but doing so in a manner that doesn't require you to build a distinct, bespoke, custom application for each platform. Because as we all know, there's the effort involved in building these applications and then maintaining them in the long term, and that can be quite a costly endeavor. And so the general feeling in the industry has been that there should be technologies and tools available that would allow you to build, a single application that could be targeted at multi-platforms and operating systems. And in that model, obviously, you have one code base in theory that you can maintain, and that would be a lot more economical. And so some of the things that developers and businesses have to choose today is, what specific application type of development do they want to choose? And this is generally sort of like a fork in the road type of decision. Do we want to build a web app? Do we want to build a hybrid app? Do we want to build a native app? And traditionally, this has been a big decision. Or, some combination of these three. And in the past, you would likely have to build, and so what people wanted was the ability to build one application. If we look a little bit at sort of the application landscape that exists today and some of the different solutions that are out there, let's start with sort of a pure native application approach. And so this would be, building either a traditional desktop application or a mobile application. So in this pure native app model, right, you build your application. So you have your code here on the left-hand side, and typically that code would interact with some kind of a platform. And the platform would usually provide some native user experience through, native UI widgets that you would use, some kind of UI events, some kind of a canvas that you could, write or display your controls on. And then you'd also have a number of different services that platform would provide to you, things like location services and Bluetooth, audio, a camera. So all of these native capabilities that are part of the device, you would like to be able to take advantage of in your application. Obviously, each of these platforms behaves differently. And so in order for your application to be able to interact with all of those different services and UI events, typically require some kind of an abstraction layer in between. And that's where various solutions have been developed over time to provide that abstraction so that you can target multiple platforms and devices. One popular solution that's been around for quite some time in the .NET ecosystem is obviously Xamarin. And Xamarin was an independent company at one point and was later acquired by Microsoft, and then evolved into sort of Xamarin Forms. There is also another very popular platform that's independent from Microsoft called the Uno platform. And then we've got some other platforms as well, like React Native, that have been around for quite some time, that evolved out of the JavaScript ecosystem. And in these cases, you basically build your application against an abstraction layer, and that abstraction layer provides the capability to target different platforms and devices. So allowing you to build UI that renders in the same manner across different platforms, and being able to access and interact with the various services that are part of those platforms as well. So this has been a very effective approach, and has allowed companies and developers to build applications using a single code base that can target multiple platforms and devices. Another popular solution that has come around, well, it's been around for a while now, and it was originally conceived by Google, is the Flutter capability.
Shaun?
And this, yes.
Yeah. Before we move on to Flutter app, can you please try closing and reopening your webcam, because I believe it's frozen in everyone's computer. We can still see your presentation, but not your. Yeah. Oh, it was closed.
I'm not sure why that happened. Okay.
Yeah, there we go.
All right. So so Flutter takes a slightly different approach. It still has an abstraction layer for accessing the different platform capabilities, at least on the services side, like location services, Bluetooth and audio and things like that. But on the user interface side, it has a native set of widgets. So a native set of components that you can use to build your UI. And some people would, prefer this type of an approach because they would say that it produces a user interface which is, more native, provides better performance, has some of those characteristics that some people need, especially for applications that have a higher level of requirements around UI rendering. And then those widgets and components that are provided to you by Flutter interact with the underlying platform in terms of the painting onto the canvas or raising events that you can use in your application. So Flutter uses a slightly different approach. It's been quite popular over time, but it's just important to understand sort of the nuances between these different approaches and solutions that are available in the industry today. So what about .NET? Obviously, there's a very large community around .NET, large ecosystem, and Microsoft over time has provided a lot of different tools that developers can use to target different operating systems, different platforms, and deliver on different use cases. The main one that we're going to focus on today is around web, desktop, and mobile. And in particular, in those areas, there's great solutions that Microsoft has provided over time. However, they tend to be distinct from one another. So on the web, you have technologies like ASP.NET and Blazor. And then on the desktop, you've been able to build desktop applications using WPF or WinForms. And then on mobile, you had Xamarin. So these were very distinct and separate technologies that you could use to build applications for each of those types of devices. However, they didn't all work together seamlessly. And so what Microsoft has been thinking about is, how they can provide a development platform that you can build a single application that would work across all of these various devices. And so, probably 3 or 4 years ago, they started talking using a code name called Maui. And so, of course, Maui does not refer to the island that's part of the Hawaiian Islands. It's not like a Microsoft Development Center in Hawaii or anything of that nature, right? Maui is a code name, and it stands for Multi-Platform App UI. And typically, instead of just referring to it as Maui, they refer to it as .NET MAUI to just basically identify that it's, a tool set from Microsoft that's part of the .NET platform. And so .NET MAUI came into existence basically last year, and it sort of was the evolution of Xamarin. So, of course, Xamarin for a long time always provided a great set of tools around mobile development. And then Xamarin Forms was sort of the successor to that after Microsoft acquired it. And then Xamarin has sort of morphed into .NET MAUI. A lot of the capabilities that were part of Xamarin have now been evolved into a new platform, .NET MAUI. And .NET MAUI was released in May of 2022, so basically around a year ago, for general availability, and was fully supported for production workloads at that point in time. So this is a relatively new set of technology, and it's been evolving very rapidly over the last year. But it's a very capable way of building native and desktop apps using a single code base that's based on C# or XAML, depending on your preference. And so you can build basically a multi-platform application, and that application can run on iOS, Android, Mac, or Windows. So this actually provides that capability that we were talking about at the beginning of this presentation, about having a single code base and a single application that can be targeted at many different platforms and devices. But if you notice in that diagram, we're talking about native mobile and native desktop. So what about the web? Because many organizations today would like to build applications that also function in a web context as well, right? They would like to have a version of the application that runs in a browser so that they can then basically provide or cater to the needs of all users, right? So anyone who's using web, anyone who wants to use mobile, or anyone who wants to use desktop. So is there a capability that can be developed that you have a single application that can be targeted at all three of these major platforms? And basically the question was, like, how are we going to be able to do that? What technologies would we leverage in order to be able to deliver this capability? And luckily, Microsoft had already been thinking about this problem, and so Blazor became the platform and the set of tooling that you could use to build such applications. Blazor's obviously been around for quite some time. I think it was originally introduced in around 2018 or 2019. And Blazor originally was focused on web scenarios, so you could build web applications that would run in a browser, and there was a couple of different hosting models that you could leverage. But there was always the idea that Blazor could evolve into something that was much more robust in its capabilities. And in fact, Microsoft provided sort of this roadmap of the capabilities from a very early stage of the use cases that they envisioned that they could deliver upon. So initially, Blazor Server was the first version of Blazor that was released that developers could take advantage of. Blazor WebAssembly also existed at that same time, but it hadn't been released for general availability yet. So that was later released after Blazor Server. There's also the ability to build progressive web applications, which are still browser-based applications. So still very much web-based, but that capability was included as part of Blazor as well. And so the next step in the evolution was around Blazor Hybrid. And of course, Blazor Native is still, well, Blazor Native is still somehow encompassed in Blazor Hybrid as well. But these are capabilities to build more native applications that will run natively on devices such as desktop or mobile. And so this roadmap provided a great sort of insight into the future of Blazor, into like what Microsoft was thinking, how it could be applied to different scenarios. And we're basically there today in terms of like this broad set of capabilities that Blazor is capable of. So modern web UI with .NET and Blazor allows you to run on the server. It allows you to run in the browser using WebAssembly. And it now has this new hybrid model, which allows you to run your web components natively on desktop or mobile. I guess the underlying technology behind Blazor is all based on components. Those components are developed in Razor, so C#, which is something that those of us who have been in the Microsoft community for a long time have been familiar with. And you basically build small UI components, and those UI components have a very rich component model that have been built around them. So providing capabilities like routing, the ability to pass parameters, the ability to consume events, the ability to do binding between your components and your backend code, and it includes some lifecycle events as well that you can hook into to hook into different stages of the rendering lifecycle. So with all of these capabilities, it provides all the fundamentals that you would expect from a component technology. So for those of you who are more familiar with JavaScript, obviously React, Angular, Vue, most of these very popular JavaScript-based frameworks are based on components, and they all have the same fundamental capabilities that you would expect for a component model. And these are the capabilities that were provided initially as part of Blazor as well. Blazor Server was obviously the original version of Blazor that was released for general consumption by developers. Blazor Server, the C# code that they write in the form of components actually are rendered on the server, and it uses a persistent SignalR connection to repaint or render the UI in the browser. But in this case, the main workload of your application is executing on the server. There's also another variant of Blazor for Blazor WebAssembly. In this case, the Blazor components are actually rendered natively in the browser itself, so on the device in the browser. And when they render in the browser, they obviously refresh the DOM of the browser to refresh the user interface. So there's a few different interesting capabilities here that have been possible with Blazor for a number of years already. Another thing that happened, I guess, a couple of years ago is that the team that works on Xamarin started doing some experimental work about how they could leverage the Blazor component model as part of the Xamarin capabilities. And so there was the experimental mobile Blazor bindings that were available for a period of time, which allowed you to build native and hybrid cross-platform apps using the Blazor component model. And then using that model, you could then take advantage of Xamarin to run those components on iOS, Android, Windows, or Mac. So these were some of the, I think, early experiments that were leading to the .NET MAUI capability that we have today. Blazor Hybrid is essentially, like I said, the evolution of that experimental bindings concept. But Blazor Hybrid specifically takes advantage of a component, a native component called a WebView component. And so the WebView runs natively in the browser, and it basically, the WebView itself is essentially a browser itself. And in this Blazor Hybrid model, you actually have Blazor components which run natively WebView to render the UI. And so this model provides the ability Blazor components that you work with in a web context execute natively on the device and to basically render UI natively on a desktop or mobile device. And so this technology is like not new if you think about it in the broader sense. The idea of building.
Hey, Shaun, it's
Yes.
me again. I'm so sorry to interrupt you. Your camera doing the same thing. We can see the presentation and we can hear you loud and clear, but your camera is frozen.
I have no idea why it keeps shutting off the webcam for no reason. This is a new laptop, so yeah.
It's
Yeah,
all
it's
right.
poor.
It's quite fine.
Okay. It's strange. Okay. So yeah, talking about hybrid web applications using this WebView approach. This is, like I said, not a new approach. There have been solutions that have been available for quite some time that have taken this approach and been quite successful in doing so. So frameworks like Ionic and others, I guess Cordova, previous to Ionic, have used this capability, but primarily with JavaScript. And it would allow you to write your application code, and that application code would then interact with a web view, typically through JavaScript, and that would allow you to interact with the user interface on the underlying platform. And this was always an approach that could be used to build applications that could be targeted at multiple devices. And definitely it was proven to be an effective approach over time. However, in order to use this approach, you had to be somewhat fluent with JavaScript frameworks. And so it was relegated sort of to that community. The other thing, you would obviously have some kind of an abstraction layer, which was a bridge so that you could still natively access all of the underlying services that were part of the platform as well. And so with this approach, it wasn't considered to be truly native because it wasn't really executing natively on the device. But it was leveraging a web view and leveraging JavaScript to provide that sort of single code base that could run on multiple platforms. Moving into the Blazor Hybrid scenario, it's important to understand the differences, I guess, in the architecture between Blazor Hybrid and how some of those JavaScript frameworks or JavaScript hybrid frameworks work. So you build your application code using Razor components, and there's a BlazorWebView which actually runs natively on the device itself. So if you're deploying to like a mobile device or you're deploying your application to a desktop, there's actually a WebView component which executes your Razor components natively on the device itself. That Blazor WebView component interacts with a WebView component, which is basically, running on the platform and rendering the UI and providing all of the platform specific capabilities that you would expect. And then Blazor Hybrid also has this bridge layer, which is similar to what Xamarin's always been able to provide around interacting with the underlying services for the platform. But in this approach, it's very important to note that it's called hybrid in its approach because it's using a web view, but your components themselves are not executing on some server somewhere. These components the code is actually executing on the client device itself. And so one of the capabilities, obviously, is you could target Windows desktop with this, and there's a specific web view component that's specifically for Windows, and it's basically leveraging the Microsoft Edge WebView 2 component. So essentially, it's WebView 2 is sort of a wrapper around the Microsoft Edge browser itself, and so that's how it provides this capability. And it allows you to target or allow run applications, both that are built using WinForms or WPF technologies today, and then leveraging the Razor component model as part of that and running them on the desktop. So basically the WinForms application or the WPF application is essentially the shell that runs natively on the desktop device. Within that application, there's a WebView 2 component, which is capable of rendering your Blazor components, and that provides the sort of the abstraction layer to render the UI natively in the the specific technology depending on the Windows platform you're targeting. And some people would ask, so what about cross-platform? So, what if I want to build a desktop application that runs on Linux as well? There's been a technology that's been out there for a long time and has been very effective for this type of development. That's Electron. There's a lot of Electron applications that we use all the time. For example, VS Code itself is built using Electron. Electron is very capable in the sense that it can run on Windows, Mac, Linux. And so there has been some experiments that have been done. Specifically, Steve Sanderson provided some insights in how you could use Blazor technology in an Electron shell. But this capability was not released as part of the initial version of .NET MAUI or Blazor Hybrid. I would expect that it would come in the future, but currently it's not one of the sort of supported methods that you can take. Really what's been the focus initially is around writing your Blazor applications and having them run either in a WPF or WinForms container or running them natively inside your mobile devices. So we've talked a little bit about code reusability already, but I mean, this is the real benefit of the technology that is known as Blazor Hybrid. Is basically you build a Razor class library, so a single set of code, and that code can run either on the web, and we've talked about some of the different web hosting models that exist today where you can run on Blazor server, Blazor WebAssembly, but that client application essentially runs in a more of a web context, or you can choose to actually run that same Razor class library as a native application on the desktop or mobile. And so finally, we have like this great ability to reuse code and write a single application that can be targeted at multiple platforms. Obviously, there's trade-offs. I mean, with any time that there's different technology approaches, there's going to be trade-offs. And so, I mean, the folks that are very much in the native camp would believe that building a truly native application, whether that's going to be a desktop application or a mobile application, believe that native applications provide a more native user experience. So they emulate the very specific nuances of the UI of the various devices more closely. They would argue that they provide better performance as well because they're essentially more interacting with the sort of the bare metal capabilities of the device itself. And typically they would provide a higher degree of hardware integration as well, maybe providing access to some of the more specific hardware integrations that are available on a specific device. Because when you basically abstract things, you might not be able to provide that same access to all of the capabilities. So that's on the native side, right? But of course, on the native side, it also means that you're building a very custom and specific application for every type of device and platform, which, going back to what I mentioned at the beginning of this presentation, that can be very costly and very time consuming, and it's hard to find the resources that are available in order to maintain and develop those applications over time. So that's obviously some of the downsides of native. On the hybrid side, you have the ability to reuse the same code, which obviously results in a quicker development cycle. And in theory, should be less expensive as well because you're actually maintaining much less code in the long term. Obviously, conversely, the downside of hybrid is that people would say it doesn't provide as great or as high a performance characteristics. It's not truly native in terms of its UI, so there might be some subtle differences between how the UI is rendered, and you might not have full access to the hardware integrations. So there's certainly trade-offs to consider, but when it comes to a lot of businesses, the cost aspects of things typically outweigh some of the other sort of native benefits that you would achieve by building a truly native app. So I wanted to provide a little bit of a demo, I guess, around the capabilities of .NET MAUI and Blazor Hybrid. And to do my demo, I'm going to focus on the open source project that I've been working on for a while called Oqtane. Like I mentioned before, Oqtane is a modular application framework. It allows you to build applications on the .NET platform much more quickly, and it was built very natively to take advantage of the Blazor capabilities for the user interface, and obviously is now able to use Blazor Hybrid as well for targeting multiple devices. So this application is fairly large at this point in time. It's about 260,000 lines of code. It's got more than 100 Razor components that are part of it. It's got more than 30 API services. It leverages a lot of sort of custom things that are capabilities that are part of Blazor, but often if you're just building standard applications, you wouldn't necessarily have to delve into them. So in Oqtane, we use a custom router. We have the ability to have plugin modules and themes, so a very sort of modular plugin capability. The application supports 4 different database engines at this point. It's fully localized, so you can localize it into any language. And traditionally, it has always run on Blazor Server and Blazor WebAssembly. So when Blazor Hybrid was released, I wanted to figure out how I could allow this same application framework to take advantage of the capabilities of Blazor Hybrid as well. And so I kind of went through the effort of doing that. I was going to share some of the insights that I found about porting basically a standard Blazor application to take advantage of Blazor Hybrid. I guess the most important aspect, I would say, when you're considering whether or not your Blazor application will be able to run on Blazor Hybrid is you must be using a client-server architecture. And so when you build Blazor server applications, it's not an absolute requirement that you build them in a client-server manner. Meaning, when you build a Blazor server application, because it's executing on the server itself, you don't necessarily have to create a whole layer of API services for it, right? Your Razor components can actually talk directly to the database. And, in some instances, that's quite powerful because you can, quickly prototype or develop applications that run natively on the server and provide that very responsive UI, which is part of Blazor Server. However, if you want to then use that same code to run it on either Blazor WebAssembly or Blazor Hybrid, it's not going to work because you don't have the layers of your application defined and the architecture defined properly. Like true client server means you truly have a client application that is distinct and separate from your server application, and it has an interface, right, which is essentially your API services that you need to interact with in order to talk to your server. So using a very well-defined client-server architecture is key to allow you to build a Blazor application that runs on server, WebAssembly, or hybrid models. Oqtane uses a backend for front-end security architecture. This architecture has become a lot more popular in the last couple of years. I guess prior to that, there was a lot of feeling in the industry, like there was a movement to move away from cookie-based security models and use token-based security models. Over time, it was discovered that that token-based models still have some limitations. There's many use cases, especially that are part of the OAuth spec, that are basically recommended to not use anymore at all. And so the backend for front-end model has come back into, or has come to the forefront as being one of the preferred models. It sounds like Microsoft is actually moving towards this model in .NET 8 with some of the security and identity improvements that they're going to make to the .NET 8 capabilities. So in Oqtane, basically it uses the distinct client-server model to have clients that run
Hey, Shaun. I believe we are experiencing another problem. Can you hear me?
My speaker just went nuts. 1 second here.
Shaun, can you hear me?
Wow. Sorry about that. Can you hear me now?
I believe yes, but
Okay.
we still have the same problem with your screen
Camera went out.
sharing.
So I
Yeah.
don't, my
Oh, we
goodness.
can see your screen.
You can see my screen, but you can't see my camera?
Yeah, I can put you on full screen for the rest of it.
Here we go. Wow. Okay. That was really odd. Okay, so we're good to go again?
Yes, they are.
Okay. I think the obviously the microphone is not going to be as good, but I'm not sure what was going on with that microphone. So
It's all
yes, we
right.
were talking.
We can hear you now.
So we're talking about backend for front-end architecture and the ability to obviously allow your users to log in. And so in the Oqtane model, obviously you would have your users log in, but all of the authentication and authorization happens on the server. That's what a backend for front-end architecture means. You don't do anything in terms of security on the front end itself, right? You always rely on your backend server for doing the authentication and authorization capabilities. In Oqtane, we also have the ability to tie into third-party identity providers. So if you want to use like OpenID Connect or OAuth 2 to do your authentication using, like maybe Azure Active Directory or any number of like services that provide the authentication capabilities, you can do that. And then there is also scenarios. So backend for front-end architecture works well when you're working within a same site sort of domain model. So you have the same sort of domain name that your applications are going to live under. And that's obviously part of the sort of cookie security model. But if you have external applications that are running on completely different domains or client applications that are running completely independently, then you would resort to using the standard JOT token capabilities, and Oqtane has support for that as well. In particular, I guess what we're talking about today, though, is the Blazor Hybrid and .NET MAUI capabilities. The other thing that was important to recognize is that as a true client server model, you have a client application that is going to be deployed to whatever device it needs to run on. And so when you're talking about Oqtane, the Oqtane client application running in a WebAssembly context, right, that client application will be downloaded to the browser and executed inside of the browser itself. When you're talking about .NET MAUI, that client application would be deployed to a desktop device or a mobile device, and it would run natively on the device. However, in all of these client-server type of scenarios, there's always the servicing aspects of that client application that you need to pay attention to, right? Because applications are never 100% static, right? There's going to be new versions of your client application that you're going to want to deploy over time, right? You're going to make enhancements to them. You're going to fix issues in them, and you're going to want the client application to be deployed to the device. And you want to minimize the headaches around doing those deployment activities. And so that's one thing that we had to take advantage of we had to build a capability in Oqtane to be able to do an auto servicing model so that it can you can deploy your Razor components to the server. And then when you run the client application, it can determine if there's a newer version of the application that's available. And if so, download that new version and load it automatically. I mean, this capability has been around for a long time in desktop applications, sort of this self-servicing capability, because IT departments don't want to deal with, deploying new versions of applications all the time to all of the different users that are out there. And so this was an important aspect to build, because this isn't something that is natively provided by the Blazor Hybrid tooling. As far as the environment configuration for running .NET MAUI, when you install Visual Studio, you need to choose the .NET Multi-Platform App Development Workload, and that installs all of the dependencies that you would need to do MAUI development. When you run your application, at least on a Windows machine, you're also going to have to enable this this Windows operating system setting for developer mode. This was not something I've ever had to do in the past, but because of the, and this was probably something you had to do with Xamarin as well. But when you're, developing more native tooling, I guess, you have to turn on developer mode. One of the things that I personally always like to do when I'm setting up a new environment is I would use the application, the default application template to build an initial MAUI application. And so you build your initial application, build it, and then run it. And that would basically prove that all of the dependencies that you would expect in your environment are set up properly. And then the other thing is in Visual Studio, if you're using the build options, you should usually choose build and not rebuild, I've found, because rebuild will have to, refresh all of the dependencies. And if you actually have your MAUI environment set up to be able to test on, all of the different device capabilities using the emulators, like the Android emulator, the iOS emulator, there's an awful lot of dependencies that you have to pull down in order to get your environment set up. And if you do a rebuild, it's basically refreshing all of those dependencies, and it can sometimes take 10 or 15 minutes. And so if you just use build all of the time, it can save you a lot of time. So in a Blazor Hybrid client application, you have and this would be referring to the Blazor Hybrid template that can be created from Visual Studio. So if you do a file new project and you choose this Blazor Hybrid template, it'll create a Blazor Hybrid application for you, and you can get that up and running. The main things that you need to pay attention to. So there's a main page.xaml, which includes a little tiny bit of XAML fragment where it would basically define how it's going to find your root component, which is your Blazor component that should be run when the application starts up. In order to make this work with Oqtane, it was a little bit tricky because there's this odd-looking syntax when you define what the component type is. And the component type basically, by default, can find a class that's part of your assembly, that's part of your MAUI solution. But in my case, I actually wanted to load a component that was part of a completely different assembly. And so luckily, you can actually specify a component type using the dynamic component capability. And so I'm basically using reflection to do get type. I can load my Oqtane app, which is part of my Oqtane.client assembly. And then I can also spin up a bunch of parameters which are expected when I'm running under the web context that I can pass to this component. And I can do that from within my MAUI application. And so this is basically how I had to make that work. Blazor Hybrid client application is bootstrapped by an index.html file, which is in your www.root folder, which is part of your client solution. And so this is the HTML file that includes the reference to a JavaScript file called blazor.webview.js, which is the JavaScript sort of bootstrap for Blazor Hybrid. The other thing to keep in mind is by default, Blazor Hybrid expects that your static assets, so these would be like JavaScript files, CSS files, image files, are all going to be packaged with your client application when it's deployed. And I'm going to talk a little bit more about this in a minute in terms of it's great. This works well for some scenarios, but has some challenges in other scenarios. The photo or the screenshot here at the bottom describes the HTML file for like that index.html file. We can see the blazor.webview.js file, and you can see that there's very little that's in this sort of bootstrap HTML file. The other thing to keep in mind is often if you're building Blazor applications, you're going to be interacting with some backend services because any application is probably going to have to load data from somewhere. And so you're going to have to configure your HTTP client to provide some kind of a base address where it's going to look to to call your web services that are your API services that are on the server. So this is where you would, like during startup, you would register your HTTP client and specify your base address. In my particular case, I'm doing something a little bit different here because I have a user agent that I'm also adding to this HTTP client so that when it calls to the server, I know that the requests are coming from my MAUI client application. And I'm doing this for a specific reason, which I'll explain in a minute. The other thing I noticed is, so during startup of my client application, and to do this servicing model that I described earlier, where it's going to download assemblies from the server automatically and get new versions for you, obviously that requires a call from the client to the server. And in an optimal world, that should be an asynchronous call during startup. The one thing I noticed, though, at least currently in the MAUI capability, is that it does not support an asynchronous main method for startup. This is a capability that does exist in other forms of .NET platforms, like even when you're building applications for Blazor WebAssembly, you have an async main capability. But for MAUI, you do not. So I basically have to call it synchronously to get the assemblies and then load them into the app domain. Hopefully in the future, Microsoft will provide an asynchronous method for this. And this is where I'm going to talk a little bit about the challenges around static asset usage. So if you're building an application and you want that application to basically run across all of the different platforms, right? So you want it to run as a web application on Blazor Server, web application on Blazor WebAssembly, and a more native application on Blazor Hybrid. You're going to build some components, right? So you're going to build some Razor components. And typically in your Razor components, you're going to include references to static assets. An example would be you're going to reference an image file. And this basically, you don't want to have to define this image file reference in different ways depending on the device you're targeting, right? You'd really like to just define it in one way. What's going to happen is when you build your application and you run your Razor component on Blazor Server, it's going to assume that this relative reference to the static asset points to your server. And so that works fine. It's going to load the image file and it's going to render it in the browser, and that's going to work fine. Similarly, if you're running your Razor component on WebAssembly, it's going to also reference the server and load that image file just fine. However, if you run that same Razor component on Blazor Hybrid, it's going to assume that that image file is not on the server, but is a relative image that is actually deployed on the client itself with the application. And so it's actually going to result in a broken image link if you run this same code on these three different platforms. So on Blazor Hybrid, you're going to have a broken image. And that isn't exactly the behavior that you would like in all scenarios, right? Because every time you create a new version of your Razor component, you don't necessarily want to have to deploy all of the underlying dependencies in terms of static assets to the client device every time. Certainly, there's some scenarios where that would provide much better performance. But if you want to have sort of this write your code once, run anywhere scenario, it would be much better if you would have the ability to reference server-based assets, like static assets that are on the server itself. I've brought this issue to Microsoft's attention quite a while ago now. There's been a number of conversations about it. I do not know if it's going to be part of .NET 8 or not. But for an application like Oqtane, this is a pretty important scenario. I've had to work around it by building capabilities into Oqtane itself, which basically determine if the request is coming from your Blazor Hybrid application, and then it basically has to turn your relative paths to static assets into absolute paths. But I don't believe that code should be necessary for developers to write in their own applications. That should be something that's taken care of by the hosting model itself. So hopefully that'll get resolved in the future. The other thing to recognize is that your Razor components, like when you're running in a Blazor Hybrid context, it really doesn't have a web context, right? It's not running under a domain name or a URL, right? It's running under an IP of 0000. And so, as I mentioned previously, you have to have these absolute paths to reference your static asset images. So there is the ability to reference things on the server, but you have to, create your static references to use absolute paths. And the other thing was authentication. So obviously, if you're running your Blazor application in a hybrid scenario, you still want the ability for your users to be able to log into those applications. And that in Oqtane's case, because it's using a backend for front-end model, we want that authentication to happen on the server. But it's a little bit trickier because there is no native sort of browser redirect flow, which is typically how things happen in a standard web application, right? In a web application, you have a login form, you enter your username and password. It actually redirects you to the server to authenticate you and redirects you back to the browser. And in the process, you get a cookie, and that means you're authenticated. When running on Blazor Hybrid, that WebView component doesn't have that same browser redirect flow that you can take advantage of. So you have to take advantage of alternate means to basically authenticate yourself on the server and then bring the cookie back to the client application. I guess with those changes, which were not that significant, I was able to get Oqtane to run on Blazor Hybrid. So basically allowing an application that had formerly only been able to work in a web context in a browser is now able to run on desktop or mobile using the exact same of Razor components. So I didn't have to significantly rewrite my application to make this work. I only had to basically create my .NET MAUI sort of wrapper application, and that allows it to work on all of the different platforms. To show a demo of that, I have let's start with my Oqtane.MAUI solution. And I said this solution was originally scaffolded from the standard template from Microsoft and only has the minimal changes I just described to get it to work. By default, I have an API URL, which is going to interact actually with a public website that's already running. This is the dnfprojects.com website. This is a website which is running Blazor and Oqtane, and it basically captures metrics from GitHub every day so that we can do trend analysis. But if I'm going to use my Windows machine emulator, so basically it's a WPF application with a web view, and it's going to basically download the components from this website, the Razor components, and it's going to execute them natively within this application and render the UI. And so you'll see like all of the content that's within this window. So this is obviously your WPF Windows application shell. But within this window is a web view, and the web view has consumed Razor components from my server, pulled them down to my client, executed them natively on my client, and rendered my UI. And that includes things such as like this particular application is using a JavaScript charting component, chart.js. That chart.js static asset lives on the server. It pulled it down and rendered it in the context of this web view. all of the data it's pulling down from the server as well. And so it has like the full interactivity that I would expect when I'm running my client application in a desktop context. I can also log into this application. I'll show you that in a moment. So I'm going to close this, and for a minute, I'm going to comment out the reference to that remote website I'm going to run locally. So, and I'm going to build this application, but I'm going to show you the Oqtane application itself. I have here in Visual Studio. I'm going to run this just on IIS Express. So this is a default installation of Oqtane, which using the latest dev branch. It has a sort of a standard template that it renders some specific content when you create your initial site. I'm logged into this instance on localhost by default. So it has a number of different pages that are part of this installation. It has a control panel with a lot of different settings that I can access. So, I mean, this is a fully functional application. And I can go back to my MAUI application now. And my MAUI application is going to interact with my my local Oqtane application that I'm already running. So I'm going to run on Windows. And again, what it's going to do is it went to that Oqtane server, right, which is at my local host address. It found any of the components that were running there, it downloaded them to this native desktop application, and it renders them. And I can choose to log in to this choose to log into this local version of the application. And now I have the full capabilities of that same application that runs in a web context, but in this case, I'm running it in a desktop. Similarly, it would be possible to run this exact same application on Android, on iOS. So you have that full capability to run the same set of Razor components without any modifications on all of the different devices. And so with that, I am going to, take some questions now because I think I'm at time for my presentation. Apologize for all the technical glitches I had today. It's not great. So I think I can go. Okay, I think I can see the questions if I go back to here. Yes. Okay.
Yeah.
And there's a lot of questions here.
Yes, but we have to be selective, I believe, because we had some technical issues and we have exceeded our time just a tiny bit.
So which would I recommend for production, experimental Blazor bindings or Blazor Hybrid? I would recommend Blazor Hybrid because it's the future. Experimental Blazor bindings never were fully supported by Microsoft. Like, they were truly experimental, just in the same way that Blazor was experimental to begin with, but then became a fully supported product. What runtime does Blazor Hybrid work on? It actually does not. Okay, so this is something that people are confused about often. So Blazor Hybrid is executing your Razor components natively on .NET on whatever device it is. So if you run, like in this case, where in the demo that I did, it was running on Windows. Those Razor components are running natively on Windows, right? They're not using WebAssembly or any other sort of technology. They are .NET components, and they're running natively on whatever device it is. So that's something that I think people don't understand, is they assume that if you're running Blazor Hybrid, that you're running on Blazor WebAssembly, and that's not the case.
Thank you.
How can I upgrade my applications from Xamarin to .NET MAUI? Oh, sorry, here. Okay, that was the question you were pulled out. How can I upgrade my applications from Xamarin to .NET MAUI? that was sort of outside, I think, the scope of like the presentation that I did. I was more focusing on how you can build Blazor Hybrid applications that target web, mobile, and desktop. I think that there is a lot of great information that's out there from Microsoft and how to upgrade from Xamarin to .NET MAUI. I'm not going to say it's an easy lift, right? There's a lot of differences between the platforms, so it's a fair bit of work. Question, would I recommend Flutter over MAUI? I guess it really depends on what you want to build and what your capabilities are of your company. So if you have a lot of Microsoft developers that are familiar with C# and the tooling around Microsoft application development, you'd probably want to consider .NET MAUI. If you have developers that want to, I guess, basically learn a whole new set of technologies, and you're willing to make that investment in them, then maybe Flutter might be a better model for that. Question, do I think the progressive web application trend will continue to grow? Yes, I do. I still think that the progressive web application model, at least for mobile scenarios, is still actually is gaining in popularity. Because companies have realized how expensive it is to build like truly native mobile applications to cater to iOS and Android platforms. So with PWAs, you can again have a single code base that runs in web and mobile. Doesn't necessarily work on desktop, of course, but if you're only needing to support mobile and web, then PWA is still a great choice. And it seems like in the newer versions of the mobile operating systems like iOS, they're finally starting to provide more first-class support for PWAs. Like they seem to be hesitant to do so for a while, and now it seems like in the newer versions there's greater support for PWAs. Is it possible to update Android and iOS applications without updating them from stores in MAUI? So I guess that's sort of the capability that I was talking about. So with what I've created for Oqtane, you would have essentially your shell application for Android and your shell application for iOS. Those are relatively static in functionality. You would deploy those to the app stores, and then your Blazor Hybrid application would have this self-servicing capability where it would be able to download automatically new versions of those components from some trusted server and execute them. So it would be able to service itself without having to resubmit your application to the App Store, because the functionality, the updated functionality is being delivered not from the App Store, but from your trusted server. What is the typical download size for a small hybrid Blazor MAUI client application? How much bloat does Blazor MAUI add? That I haven't measured that, but I mean, just like I guess WinForms, WPF, or even native mobile applications, right? There is always some level of dependencies that you have to deliver along with your application. So this question is a tough one to answer. Like in the context of Blazor WebAssembly, right, where you're transferring .NET assemblies from your server to your client browser, and there's some initial latency concerns around that. Because that's happening dynamically in real time. So when a client browser connects to a server, it has to download those bits. In that scenario, of course, the bloat is a major concern. In the case of Blazor Hybrid, and depending on how your deployment model works, it's pretty normal that there's a bit of a delay as you install that initial client application, whether it's a desktop application or a mobile application, right? We're used to that on our phones. I want to install a new application on my phone. I have to go to the App Store. I have to choose it. It spins for a while. It takes a while to load. Like, it's not an instantaneous experience, right? once I run the application, then I expect an instantaneous experience. And that's what you would get with Blazor Hybrid, because at that point, the application's on your phone, it's running natively. Right? The only thing it needs to do is get data from the server. So it's important to recognize sort of where the different workloads are and the different expectations of the different client users. What's the average memory consumption of .NET MAUI? I have not measured memory consumption for .NET MAUI. And I guess it would just depend on a lot of things, the size of the application and many other things. So I think that I'm probably at time. That's why
That's
we need to
all
wrap
right.
up. Okay.
Yeah. If you would like to get in contact with Shaun to ask more questions, you would be able to find his social media accounts in the speakers section of Shaun's speaker page. So thank you so much for your time. It was a great pleasure to have you on board with us for this ABP conference talk. Well, hope to see you in next ones.
Thank you. I appreciate it. It was a great opportunity to speak to your audience.